Here's the C3 paper from June 2013. Question 1 is an algebraic long division, and I do think it helps to write that there's 0x here, because then things will line up better. You need to divide that by x squared minus 4. So what do you times x squared by to make 3x to the power 4? Well, that's obviously 3x squared. Let's do 3x squared multiplied by x squared minus 4. So we get 3x to the power 4. And then 3x squared times minus 4 is minus 12x squared. So let's make sure everything lines up and write that there. Do a takeaway. Nothing there. Minus 2x cubed goes here. And minus 5, take away minus 12 is plus 7. So we've got 7x squared. And we've got nothing to bring down. Now go through the whole process again. X squared into minus 2x cubed. That's minus 2x. So minus 2x times x squared minus 4. That's minus 2x cubed. Minus 2x times minus 4 is plus 8x. Let's line it up there. Do a takeaway. 7x squared minus 8x, and then bring down the minus 4. Finally, x squared into 7x squared is 7. So it's 7x squared, and it's going to be minus 28. The last takeaway, we've got minus 8x, minus 4, take away minus 28, that's minus 4 plus 28, so that's 24. So they want it in the format ax squared, so a equals 3, plus bx, so b equals minus 2, plus c, so c equals 7, and then it's d. The remainder is dx plus c, so d is minus 8, plus e, so e is 24 over x squared minus 4, which is what we've got here. So these are our solutions. In question 2, we have to draw 3 graphs. The graph of y equals ln x is that. It crosses the x-axis at the point 1, 0, and x equals 0 is an asymptote. So that was part 1. Now part 2 is just the mod of that. So it's the same graph up until there, but then it reflects in the x-axis. I should have put in x and y. Not that you get any marks for this, but it's good math to do so. So again it's 1, 0, and again it's x equals 0. Now in part 3, let's take it one step at a time. The x minus 4 is f of x minus 4, so it translates 4 to the right. So we've got that there. So this point is, instead of being x equals 0, is x equals 4. This point here, instead of being 1, 0, is 5, 0. And then it's minus f of x minus 4. So this was f of x minus 4. So minus that reflects it in the x-axis. So we end up with x equals 4 still being an asymptote. It's like this now. And it crosses the x-axis at 5, 0. Okay, in question 3, let's take the equation they've given us and expand using the relevant formula. So it's 2 cos x cos 50 minus 2 sin x sin 50, and that equals sin x cos 40 plus cos x sin 40. Now they want the answer in terms of tan 40, but we've got here some 50s, and what we need to do at this point is to think about the fact that if we've got a 40 there and a 50 there, that makes a right angled triangle. Let's take A, B, C. So the cosine of 50, there's 50 here. The cosine of 50 is A over C, and A over C is simply sine 40. So instead of writing cos 50, we could write sine 40. So therefore we get 2 cos x sine 40. What about sine 50? The next bit's got a sine 50 in it. Well, sine 50 is opposite over hypotenuse, so that's the same as cos 40. Sine 50 is b over c, cos 40 is b over c. So we can write this as 2 sine x cos 40 equals the right hand side. So let's put the reason in there. Now the equation they want us to get has tans in it. This has got sines and coses, but if we divide everything by cos x and by cos 40, we should get the answer we want. So now let's divide by cos x cos 40. So we get 2, as cos x, okay, divided by cos x, that's 1. Sine 40 divided by cos 40, that's tan 40. Next bit, we've got sine x divided by cos x, that's tan x. But we're divided by cos 40. Cos 40 divided by cos 40 is 1. Then we've got sine x divided by cos x, that's tan x. Cos 40 divided by cos 40 is 1. And cos x divided by cos x is 1, and sine 40 divided by cos 40 is tan 40. So we've got a tan 40, 2 tan 40 here, 1 tan 40 there, that leaves tan 40. We've got a minus 2 tan x here, and a tan x there, 2 plus 1 is 3. In other words, tan x is 1/3 tan 40. Make that a proper divide sign as required. So that's part A done. Let's move on to the next slide to do part B. Now the equation in part B is exactly the same as the equation we used in part A, except instead of writing x, they've written 2 theta. So therefore we can say that tan of 2 theta is 1/3 tan 40, because we've had that result before. We had tan x is 1/3 tan 40. So therefore 2 theta is inverse tan of 1/3 tan 40, which is 15.63 degrees. We're in degrees, there's a degree sign there. 195.63 degrees. 375.63 and 555.63, so therefore theta is all these numbers divided by 2, and we need the answers to one decimal place. So let's divide all these by 2, and we get our 4 answers. We're told that theta is between 0 and 360. If we'd taken a bigger value here at the end and divided by 2, that would have been outside the range of 0 to 360. Now I've got question 4. And we need to find the turning point. So at a turning point, f dash x is 0. F dash x is 0. So we need to differentiate this expression. So it's a product, it's 25x squared. Let's differentiate that. That's 50x and leave e to the 2x alone. And then let's leave 25x squared alone and multiply it by the derivative of e to the 2x, so that's 2e to the 2x, differentiate 16, that's 0. So if f dash x equals 0, then this line above here is 0. There's a 50 in both expressions, 50 there, and 25 times 2 is 50. There's an e to the 2x in both expressions. And there's also an x in both expressions. So that just leaves 1 for the first term, because that is the first term. And then 25 times 2 is 50. Yeah, we've got that. Oh, that's x squared. So we've got a plus x. So that equals 0. Now e to the 2x doesn't equal 0. 50 doesn't equal 0, but x could equal 0. So therefore x equals 0, or x equals minus 1. Now if we put x equals 0 back into the original expression, f of 0, that's a 0, and that works out to be minus 16. And if we put minus 1 into the original expression, then that works out to be exactly 25 e to the minus 2 minus 16. We wanted the exact coordinates, so therefore the coordinates are 0 minus 16 and minus 1, 25 e to the minus 2 minus 16. In part B, we've now got f of x equals 0, so you can put that equal to 0, so therefore 25x squared e to the 2x equals 16, therefore x squared e to the 2x is 16 over 25. Let's square root both sides. Square root of x squared is x, square root of e to the 2x is e to the x, plus or minus 4/5. They want it in the form plus or minus root 4/5. We've got e to the x on the left hand side, so that becomes e to the minus x on the right hand side, as required. Then in part C, we know that x0 equals 0.5. Let's put 0.5 into that iteration, and x1 works out to be 0.485. x2 works out to be 0.492, and x3 works out to be 0.489. Just substituting those values back into the expression. And then in part D, it's clearly going to be round about 0.49, so let's take 0.49 and add 0.005. Let's work out what that is. That works out to be 0.485, a bit confusing because it's more or less, well, that's the next number we're going to choose, 0.485, but that's just coincidence. Let's put 0.485 in and we get minus 0.487. Then we need to write out the sentence, the boring sentence. So there's the boring sentence. You never really need to write out that f is continuous. I've never seen a mark scheme that requires that, but it's good math to do so. There is a change in sign. F is continuous, therefore x is 0.49 corrected 2 decimal places.